gives us the charge of the alpha particle. So Q is 3.2 times 10 to the negative 19 coulombs.
That's in the 19, okay. Yeah, mine didn't print out that well, so it's
Okay, we get the mass of it as well. So 6.7 times 10 to the negative 27 kilograms. It's accelerated by a potential difference. So my voltage is 1200 volts. And then enters a magnetic field with 0.25 Teslas. So that's your D value. And it asks what the magnetic force is on it. So I'm looking for the force. Okay? So I flip back to that sheet. So my magnetic force is so I got the electron, I need the velocity of it. I'm given the potential difference on it, right?
yeah.
So I've got B, I've got E, I need to find a velocity somehow. And I've got voltage. So how does that correspond to what we're doing here? Well, do I need that voltage? Okay. Man, I'm going through these for a while. Enough particle. Potential difference 1200 volts, and then enters magnetic force acting on it. So I need I don't have a radius. Okay, just give me a second here. I'm gonna have to look back at this.
Yeah, between like, that's kind of as far as I got, just labeling, but I couldn't really figure it out either.
I'm missing something obvious here, and I don't know what it is.
Anything to do with the degree, like with movement 90 degrees?
No, that just gives me my, that just means I have my maximum force, which is VEB.
Okay.
I'm just trying to figure out how that, I need to figure out how that voltage factors in here.
Yeah.
And I don't think these are the right sheets. I'm just trying to find the answers now. 3, 4. Just a second. Still not there. All right, I got it from a different question. Okay, so this is beyond what we've got. We've got where we're at with this. Okay, we aren't quite there yet. I haven't done enough with this, so this is not your fault by any means. So kinetic energy. I have to, in order to get this, I need to get the velocity here, right? Okay? Now, we haven't talked about kinetic energy yet. We have to talk about it. That's our next section that we're going into, is with energy. And so work is Q over V. All right, so that's your charge over your potential difference. I think that's the right equation. Just look that up. Q coulombs per volt. The Q times V or Q over V?
I had it in my other. I'll go downstairs and check.
No. Just wait. I'll look it up in your book. Just wait. I'll find it. It's not a big deal. I don't know why I can't remember this, but anyways. Work. C is Q over V.
So B is equal to W over Q. So
Okay.
Q is equal to W over V. Are you looking for W?
Yeah, what is W equal to?
W is equal to V times Q.
V times Q. Okay, perfect. Thank you. So I got Q times V, so that's your voltage, right? Kinetic energy is 1/2 mv squared. So, and work in kinetic energy, work is actually equal to the change in kinetic energy, but in this case we use it as equal to 1/2 mv squared. So this is something that you haven't been shown this question on. Okay? So my velocity then is 2q voltage over m, and that's equal to v squared. So let's find out what our velocity is. So our velocity is going to be the square root of 2 times 3.2 times 10 to the negative 19 times 1200 divided by the mass of 6.7 times 10 to the negative 27. So let's get our velocity first. Okay, so I'll work that through with you. So I've got square root 2 times 3.2 exponent negative 19 times 1200 divided by 6.7 exponent negative 27 equals, so I get a speed of 338,565.8956. Just put 0.9. Okay, so that goes into here for, is that what you got?
Yeah.
Okay, so now I'm going to times that by my 3.2 exponent negative 19 times 0.25. So the force I get is 2.709 times 10 to the negative 14 newtons, which is what we get there, don't we? Yeah.
Yeah, that's okay.
Okay, sorry. Yeah, so that all comes from, this is the application right here, is work and kinetic energy and converting from that voltage, that potential difference, and converting it to velocity then.
Yeah, that wasn't really anything I saw before, so I didn't.
No, you haven't seen it yet. You've not seen that yet. I know that for sure.
So is there some questions I had before that? Before these?
No, nope. That was it. This is the start of it. The easier sheet is actually the one sheet is the second page there. The force between parallel conductors is usually the one I start on. You kind of jumped ahead. I mean, that's the way I sent it to you, so I understand why you went there. But okay, so that was question 6. Did you want to go through any of these other ones here?
Yeah, I think on 7.
Yeah.
2, I didn't really, like, I thought I was doing it right, but I didn't like straight answer.
Okay, well, let's have a look at it then. So I got 2 parallel conductors. Yeah,
It's 5 meters long and 12 centimeters wide, yeah.
okay, so 5 meters long and distance apart is 0.12 meters.
Yeah.
Okay. And the current in one conductor is twice the current in the other. So my I1 is X, my I2 is 2X. And the force between them is that, and it wants to find what's the magnetic force, what is the current in each conductor? Okay, so I have this here. Yeah, so I have F equals 2K L I1 I2 over D, right?
Yeah.
So I've got force 3.6 times 10 to the negative 4 is equal to 2. 1 times 10 to the negative 7 times 5 times 2x squared. And that's over 0.12. So x times 2x is 2x squared, right?
Yes.
So let's find out what x is. And that's going to be the square root of 3.6 times 10 to the negative 4 times 0.12. And that's divided by, okay, so I take 2 times 1, which is 2. 2 times 5 is 10. 10 times 2 is 20. 20 times 10 to the negative 7. Square root all that, and that should give me what my x is. So the current in one conductor. Okay?
Yeah, I'm just checking to see if it works. I get 3,286.
I get that.
I messed up. Just give me a second.
Yeah, no worries. So it's square root of 3.6 times 10 to the negative 4 times 0.12 divided by 20 times 10 to the negative 7.
Yeah, I still get the same answer.
All right.
Are you doing any brackets at all?
Nope. Nope.
Okay, that's why.
So I like it opens the bracket when you hit the square root, right?
Yeah.
And then it's just 3.6 exponent negative 4 times 0.12 divided by 20 exponent negative 7, and then close the bracket.
I got 4.648.
Yeah, that's what I got too, Rory.
Brendan, type it all in without the square root first. Do the 3.6 times 10 to the negative 4 times 0.12.
Here we go, 4.64. Yeah, I got it. I did square root first. I mean, the square root first. I just put brackets in the number. But what I did before was I put 2 sets of brackets. So like square root bracket 3.6 times 10 to the negative 4 times 0.12 bracket over bracket 20 times 10 to the negative 7 bracket.
Yeah, too many brackets.
Yeah. So that's what I did the first time too. Like I did everything the same, but I just got that 32,000.
Okay, cool. All right. Did you try 8 and 9, or do we need to do them? What are you guys thinking?
Well, I tried, but I still think 8. I got through it now. It's even 9.
9, no go. Okay, nine's a little bit trickier because you're not looking for one particular variable. You're looking for a ratio of the charge to mass. So you're looking for a ratio of Q to M. Okay, so for a particle accelerated to a velocity of 6, so a velocity is 6 times 10 to the 6 meters per second. That moves in a circular path. So I've got a radius of 0.018 meters. And a force of 3.2 times 10 to the negative 2. Oh no, that's a B. Tesla. Okay. So if I look at the two equations for force, and because it's moving in a circle, so I've got F equals mv squared over r, and F equals BEV. Okay? So one is a maximum force in a magnetic field. The other one is the force that's generated by moving around in a circle. And this is why I'm saying when we look at a solenoid, it creates a huge magnetic force inside that air core because the current's moving and it's also the spinning of the electrons, right? So if I let them equal each other, I get BEV is equal to mv squared over r. All right? Now what I'm going to do is I'm going to divide the m to this side. So I'm going to end up with E over m here. Okay? So I'm dividing that down. So that's a charge to mass ratio. Okay? And then I'm going to move the B and the V down here. So I'm going to end up with V squared over BV R squared. So that's going to cancel. So all I need to do in this question is take my velocity, divide it by my B times my radius squared, and that gives me my charge to mass ratio. So it's a little different in the sense that, or I could put Q there too. I don't need to put an electron. Does it say anything about electron there? Right. So now you have velocity over BR squared. Okay, and this time you need to use brackets for it. So you've got velocity 6.6 divided by bracket 3.2 exponent negative 2 times 0.018. And I get, same answer, 1.04 times 10 to the 10, and the ratio is coulombs per kilogram.
Yeah, I didn't realize you had to combine the two. I just wasn't really sure how they caught it, but
yeah,
none of those formulas had it all. Really.
That's right. Yeah, no, I understand what you're saying, for sure. Okay. So if you flip to the back side of that sheet, the first two questions are two of the questions that we kind of went through. The first question is one we went through, and the second one is very similar. It has a force per meter. So you have to understand that you're talking about a length of 1 meter or a distance of 1 meter. Okay?
Right.
But
so let's take on, I guess that's part A, and then state, so it's
Ampere's rules.
That's my answer. So sorry, I'm just looking here.
Oh,
So
good. That sheet appears again, I think. Yeah.
So what does it say on top of it?
That sheet appears again. You're going to, the actual whole worksheet is 2 pages over.
Okay.
So you don't have to do the back side of that sheet. The next thing you should do is that force between parallel conductors. Okay? And then you'll get to that other sheet after the answer key one it says at the top.
Okay. So that actually is that the answer to your I'm sorry.
No. It just says it because I put the answers on it.
Okay.
Like I gave the answers for every question. But how to do them is I have that. Hold on a second here.
I think you put it in the saw someone else getting click on it all.
Well, what I'll do is for that worksheet 5, I'll post this. Is Edmodo or the assignments better?
Yeah.
Which is it better on Teams if I post it there?
For some, it's easier to upload it. I think on Teams should be.
Yeah, same for me.
Okay, so what I'm going to do is I'll scan the actual solutions, and I'll post them on Teams for you today. For worksheet 5. So that's the one that starts with at the top here. It has that the theory at the top.
Yeah, I'm looking at that right now.
Okay.
That's one that's actually.
Yeah. So I'll post the answers, the solutions for that sheet on Teams right away here. I'll go I'll go scan it and I'll send it to you.
You just want to do all those questions over the weekend.
Yeah, let's get that other one done. It's an easier one, the parallel conductors one. Okay, there's 5 questions there. And then start in on part B. Just get started on it. So do the first 2 questions on part B on that one. Okay? And then Monday we'll finish that worksheet 5 off. And then we'll see where we're at. I may give you a short assignment on it next week, and then I wouldn't mind getting into a different section, but we'll see how this goes.
Are we behind if it's
Yeah, we are. But yeah, we certainly are.